Brie, can you hear me? Amelia, Daddy's home. Amelia, Daddy's home. Open the front door. Go unlock the door so that Max can come in the front door because the garage is a little weird. Why is Max crying? You have your meltdown in the house. That good of a day, huh?
take home. You have plenty of candy. You have, your Tic Tacs are here and there. You have plenty of candy. Well, then Max is going to take the other ones out of the bucket there. You got a problem with that? Max, take those Tic Tacs. Let's get them. Amelia doesn't want them. Amelia's got them.
Yeah, don't be nasty.
So we have a customer that we're doing like a big project for, right?
Okay.
So we have like 20 jobs. 20 employees. And you have to. So they got their first like 3 invoices, and one was a little under, one was a little under, and one was a bit over. And they were like, yeah, it's no problem, we can change our PO, blah, blah, blah. Can you do an estimate on how many the rest of your jobs are going to go over and how much they're going to go over by? Well, if I could do that, and things like that, I would be in a sports book in Vegas, making a lot more money. You can open this for you. Like any number of things can make a job go over. Use more nitrogen than you thought you were going to use. Takes longer than you thought it was going to take. The customer tells you to stand down and wait for 12 hours because they have a safety issue. Like, there could be any number of things. Job takes more nitrogen than you thought it was going to take, and consequently you have to end up getting nitrogen from further away than you originally thought you were going to get it from, and now you've got way more mileage charges and standby time. And like, there's going to be any number of reasons and ways a job goes over quote. I can't tell you which ones and by how much. We just had a job that we've done 3 times before, and the average, like, the max price on it was like $40,000. The average price was like $37, and the other 2 were both at $35. So I quoted it at $37. Final bill came in $150,000 because they had to stand by for 3 days in the middle of the job. Because they were having issues elsewhere and couldn't like have us keep flowing. And they had us just wait for 3 days.
Well, like, you have to charge them for that because
Yeah.
you worked out outside today?
Yeah, I didn't work out.
Brie, are you there?
He would not leave me alone. Flying ants kept landing on me, like dozens of them. Like I constantly was doing this during yoga, no less. So you're like, I couldn't get into a rhythm, and I got 3 phone calls. I couldn't get in any kind of rhythm or flow. Oh, and my phone overheated once. there was no sun, or no shade, rather.
I need my phone. I need my phone.
Thanks, I didn't think I'd get that. Was going outside. Hi, get away from me. She loves it.
Do you want me to leave the bottom way out?
Yeah, because I don't know what I'm eating.
You need to stop whining, number one. 3 hours, 27 minutes of sleep, that's good, right?
You were up when I came. A sucker? No, you're gonna have food first. Yeah, I need to trim the fan. I did it last year. It worked out really well. No, it lasted for months. An oily hanger. What? I can't see, but you gotta bring it over closer. Okay. So this one is Ant-Man, right? You can shrink down to the size of an ant, or you can get as big as a house. Ant-Man. And that's Nebula. She's an alien.
I'm supposed to tutor at 5:30, and she has to leave at 6:30. So.
Max, what kind of
Alright,
food?
we work from 5:30 to 6:30.
What kind of food do you want for dinner? Do you want me to put a little spaghetti and meatball together for you? Killing me, Smalls. Raspberry fudge brownie.
Oh, that Max likes that one. I don't know if Amelia does. I do. I do as well.
Ice cream?
Yeah, isn't that what you were talking about?
Yeah, I just said you're killing me.
Oh, dang it.
That's like
I left my wedding ring in my car with my Fitbit.
Okay.
Thank you. Thanks, love.
Maybe, what am I gonna eat? Do you have any pepperoni?
No. Those would be good with that Ritz crackers, though. Is that what you were thinking?
No, I was gonna make myself a pizza toast because
Probably eating. Oh.
we don't have much.
We'll make some chicken tenders or
One of us is gonna do it, one of us is gonna get. Oh no, I'm not 2 steps. Max's lunch for tomorrow is started.
Oh, I lost a 3. That's the problem. That's actually kind of a good thing because. All right, so this cancels me.
I'm surprised she's already hammering. Like,
Please, -3 to 3 be an answer choice. Woo!
I'm surprised he's already putting on the cross beams.
She's not here yet, so.
And that he wouldn't wait to take her to cement the set. What do I know? I don't really know anything about that.
I feel like we might have a fence like by the time your parents get here tomorrow.
I don't think so, but I think by the time we get back from Great Wolf Lodge, well, she didn't hear that, but by the time we get back from Dallas.
That's what I keep saying, Dallas.
Does she know we're doing anything, or?
I told her there's a surprise. She can't
Does she
hear.
know we're going on a drive
I don't know. I've been kind of just.
to stay in a hotel?
She doesn't. I don't think.
Are you going to tell her tomorrow?
I don't know.
Or are you going to try and surprise her completely?
Do you think, real quick before she joins here, do you think that, number one, if you wanted to do something with it, like if you just want to, because I feel like it could be able to find, like, I feel like when we put that with these kinks it's fit.
Anything that we can draw wise? I didn't notice anything either.
Yeah, I didn't either. But,
Because I was just thinking, just to be able to write, happy birthday, and like, we can do that.
Look on like the hoops and little big dress or whatever.
Yeah. This is a pretty. That I put on pasta, but it's 2 things out of the fridge.
Yeah, so here, so here is, oh, I swear I have that receipt. So I bought these and then I realized we already had some. So, because this is This is almost $30 right there, so like you, and like this expires, so I'd rather just wait till you know, so like if you feel like, I don't know, like, you know, and then, so I'll just leave that over here with the receipt, cause that can go back to Kroger, and then, like I said, right here, I don't know if there's anything. I don't know if it was really bad idea. Like, I bought the chips that your mom wants. And they were block of cheese. With a block of cheddar, yeah. And then, see if you can get like, just like a block of cheddar. That wouldn't be bad. Oh no, we have a block of cheddar. Cause that's like a good snack to have it, here. So.
I was out in the sun all day on Saturday, you know. I was like, oh, you know, 55 minutes in the sun, you know, like.
You had a shirt on.
Yeah, I didn't get burned on the back of my neck or my bald head.
You were red though.
This hurt more. I'll bring a few of these shirts up with me though, because I feel like,
They're softer on your
well, if you
abrasions.
need to wear anything too, these dry pretty quickly, you know.
Oh yeah, that's a good idea. Alright, that's 1 through 7. Alright, 8, 9, 10, 11, 12. Okay, so this is only 12. Hey, so if I got 7 done, that's over half. And I got answers for all of them. It's always promising. Hey, Tom, come here for a sec. I'm just curious.
What?
You think this one is me, right? People 1 and it's me, right?
I would think so.
Okay. not seeing what else in here.
Well, and you could also probably like text them, right?
I just called her and it like went right to voicemail. So I don't know if she's just like on her way. Cause she got out of cause she's like kind of, I think, trying to meet up like between classes, which is fine. Cause I'm just like kind of working the problems and then.
I didn't know what to do with that.
Is it like random stuff? Like snacks? I think it was leftovers from the Stuco trip.
Mm.
So like
This
just.
was like Butterfingers and
Yeah, it was just leftover stuff from the student council trip, so it can be eaten or whatever, but.
the game comes out today.
Yeah, I have a few students that work at the movie theater, and they're like,
Probably gonna have a miserable night.
is someone like going in your car?
I'm ready to take my
No. Those people are probably gonna have a rough night.
Who?
People who work in the movie theater tonight. and
Oh,
tomorrow.
yeah, I thought you were talking about like those people, and I was like,
People who work
she
in the
said
movie
that
theater
like she's, yeah, like it's
tonight,
crazy.
Tomorrow and Saturday. Hey, Amelia, wait. Before you take a bath, do you want to take a ride with me to Kroger? We can go take this stuff back, and we can pick out a small little cake that we can write your name on, so that you can have a little cake tomorrow for your birthday.
No, I just want to with the one.
Oh, I think Daddy needs your help to pick it out because he doesn't know whether to get which cake to get. He doesn't know which one looks best.
Yeah, pick the happy birthday one.
Daddy, do you know what that looks like?
I would like you to come with me.
No. You just,
And Amelia, I have to help one of the teenagers, so I can't wash you up right now. But at 6:30 we will, okay?
I wanna pick me up.
I know, baby, but I'm not there to wash you up right now. I'm thinking this has to be the root test.
Wait.
Take.
Movie's gonna make like $500 million this weekend.
You think it's gonna be that wild?
It's gonna be insane. It's gonna make it's gonna be the number one grossing movie of all time.
No way.
And
Why?
let me see. Why? Because this is the end.
Oh, so it's like a culmination.
Yeah, I mean, it's all still gonna keep going, but this is the end of their storyline. Like,
Because there's nobody.
this
Oh,
is
I saw a really funny thing.
22 films, 11 years.
Yeah, love.
Can I show you which two presents I want to open?
Which ones? You could definitely open the little one. Well, think about it. You could open the little one first, but not yet.
Unadjusted for inflation,
Daddy, you have time to watch me.
Avatar made 2.8 billion. Avengers Infinity War made 2.05. I think this is gonna be bigger. Adjusted for inflation, it's gone with the wind.
It's gone with the wind. What about Titanic, though?
That's
Up there.
adjusted for inflation. Unadjusted for inflation, Titanic is currently second.
After Avatar, right?
Yeah.
Daddy, can you watch me now?
She needs an actual, like, she's dirty.
Amelia, honey, don't you want to go to the store with me?
No.
Tell her if she goes to the store, then you could do it. Hey there. Oh, no worries. You're probably like, what is this lady doing? Yeah, I'm all logged in. So let's see. And then I was just sitting here working them, and I got through number 7. So I think maybe if you want to like just go and put in the answers and see if they're right, and then I can like work through them, you know? That way, yeah. Okay. So, I wonder if I could do this. Okay, do you see me? Sure. That makes sense. Okay. So you have this thing printed out, right? Okay, so do you have it like do you have like your account pulled up on another tab so we could like just like put in the first 3 answers and just check if those are right, and then I can go through those 3 and then see how that goes? Because you have to leave at like 6:30, right? Okay. So we'll just kind of like do a few, and then if you're available later, I can finish up. Because like I can even go through the first few, and then you might kind of get the process, and I can give you like my answers for the rest, and then like you could try to go through the other ones, and you know, in the meantime or whatever, and then I can get back to you probably about like 9:15 after I get my kids to bed. Yeah, well, well, keep your head up. I mean, you're at a research university. This is definitely like, this is what happens. You just got to keep your chin up. I know that you are good about seeking out resources. I think maybe you just waited a little too long. And I can like email you my notes, but like there's certain things that I notice, like the root test, like I don't cover that because it's not part of, like, I mean, I can show it to you, but like even if I emailed you my notes, it won't be in there because it's not part of like my curriculum. Yeah. I once took a music class that I got a B in. It was like literally the hardest B I ever got, because you would walk in and they would just play music and they'd be like, name all the instruments. And I'm like, I literally would just write down names of instruments I knew because I had no idea what I was doing. So hold on. This homework though, this homework 21, this is your, like, when is do you have a test on this, or is it your next test is your final? Okay. Okay. Okay, yeah. If you can get it to me, because then I can like work it first, and then because if there might be some stuff that like I haven't done in a bit, so I might need to look it up or whatever. But okay, do you got your thing pulled up? Okay, so let's just try these first three. So I got r equals 1 on this one. And then let's do 2 and 3 because they're similar, I think. And then I got r equals 0. Oh, you can't see what I'm doing. Okay, so like you said. Okay, well, number 3 is related to that. So hold on, let's pause there. And then for 4, I got infinity. I got r equals infinity. And then this number 5 is like goes with number 4. So then for number 5, then I got choice 1, negative infinity to infinity. Oh, okay, so let me go through 1, 4, and 5, and we'll just kind of see how that goes. And then you might kind of pick up on some stuff. All right, so let's see. So you've got that, so I can just write on some paper. All right, so, okay, this idea of a radius of convergence. So like all these questions are about a radius of convergence and interval of convergence, okay? So basically, for a power series or for these series, there's like 3 choices, okay? So you've got 3 options. You're either going to converge at the center, okay? You either converge only at the center, okay? And then you can converge for all real numbers, for all numbers, right? And then this third option, that's the kind of the interesting one, is when you converge for what they call an interval of convergence, meaning, so say you converge when you plug in the number 1, or that, because that's your center, because everybody is going to converge at the center. Now, if you converge, say, from 0 to 2, if this is your center here, okay, that means that when you plug in n equals 1 into that big series thing, you're going to converge. And then it also means if you plugged in other numbers, if you plugged in 2, it would also converge. And if you plugged in 0, it would converge. Then this would be your interval of convergence. Would be, you would write it as like either 0 to 2 like that, or you might see it written like 0 less than x less than 2, something like that. Oop, wrong way. Okay, and that's your interval of convergence. Now, some of these questions are asking for your interval of convergence, and some are asking for your radius of convergence. So the radius of convergence is how far from the center do you go? So like from 1 to 2 would be 1. So here, the radius of convergence would be 1, right? And if I had a different one, so say I had something where the center was at 3, okay? So if you had something where the center was at 3 and you converged, from, let's not do 6, let's do 5, and then 1, okay? Your interval of convergence would be from 1 to 5, okay? Your radius of convergence would just be that amount, which is 2. Because you're 2 on either side of 3. So you kind of see the difference between a radius of convergence and an interval? Okay. No, you're good. Okay. So On number 1, I did the ratio test. So the ratio test basically says we're going to take the limit as n approaches infinity. And if you looked it up, it would say something like a sub n plus 1 over a sub n, and it's the absolute value. And we want that to be less than 1 because it converges if this. Okay, it converges if this limit is less than 1. So that's kind of our goal there. So I'm going to take a look. I'll just say, all right, the limit as n approaches infinity. So then you're like, well, what does this mean? Well, this means you plug in an n plus 1 wherever you see an n. It's still in the absolute values. So I'm literally just taking that equation from the first problem and doing 7x to the 7 and then to the n plus 1. And instead of just square root of x, it's, square root of n, it's n plus 1 under the square root. Multiplied by, because see how this is like, so that's this part right here. This is the a sub n plus 1. And normally we divide it by the original. So I'm going to multiply it by the reciprocal of the original. And go from there. So here's kind of my setup. I plugged in n plus 1 wherever I saw an n. And then I divided by the original, aka multiply by the reciprocal of the original. Now, this might be different from some of those convergence tests that you've done before because notice how we have x's and n's. So you have to kind of keep everything straight. Here I'm taking the limit as n approaches infinity. So that's what I'm concerned about, meaning that x is going to be something that I'm solving for. I'm trying to find the values of x that make this limit less than 1. Because again, by ratio test, if it's less than 1, then I know it's going to converge. Okay, so when I plug that in, now I just have to kind of clean this up. So just to remind yourself of some of those rules that, you know, when you go to cancel with exponents. So this 7 takes out that 7. And remember your rules. I'm just going to write something like off to the side. So remember if you had like x to the 5th over x to the 3rd, if it was the same base, then you subtract the exponents. So that would be x squared. We're going to apply that same concept over here with this x raised to the n plus 1 and this x raised to the n. So if you need to do it off to the side, like while you're getting used to it, you can. But basically we're saying this divided by this is going to be the same thing as x. You just recopy the base. And then n plus 1 minus n is just a 1. And left up in the numerator is just an x to the first power. And you might not want to put that first power there so it doesn't look like a derivative or something weird. Okay, so friend there, and feel free to like interrupt me or you can type something if it's easier because I think you muted me on the phone so that you didn't get the feedback, I think. So, no, that's fine. Just, yeah, no, I can hear you. And if you need me to stop, I'll try to keep my eye on my laptop too. So just type stop or something. Okay. Okay, that's fine. Okay, So again, here's the concept of this limit as n approaches infinity. So the n is the variable that I'm like plugging in the infinity to, meaning that this x is almost, you treat it like it's a constant, and you're going to do this trick like every single time. You take this, the part with the x, not the part with the n's, because the n is being affected by this limit. The x is not being affected by the limit. So we're going to take this x and we're going to pop it out front, and it's going to be in the absolute value bars, right? Because these absolute value bars are still there. So I've got the absolute value of x. I just took this, popped it out front. The limit as n approaches infinity. And then I've got the absolute value of square root n over square root n plus 1. And you might get good at these and kind of do these like pretty quickly in your head or whatever. But from now I need to evaluate this limit. So here's the step where you're like, your goal is to kind of get rid of this. So you need to evaluate that limit. And when you're taking a limit approaching infinity, you're going to be using your horizontal asymptote rules. That's like from Calc 1, right? If you have a limit approaching infinity, you want to try to use your horizontal asymptote rules first. So that's like, is it bigger in the bottom? You know, big booty bottom drops you to 0. Is it top heavy? That means that it's approaching positive or negative infinity. Or the one that shows up a lot is when it's balanced, meaning that the exponents are the same. And that's what we have going on here. And you grab the coefficients, right? Just like if you had like, you know, if it was 3x squared over x squared and you were taking the limit as n approaches infinity, if it's balanced, you grab the coefficients. You might remember that from pre-cal even. So that's the strategy I'm using right here. We say that this is balanced, okay, because it's the square root of n here, square root of n there. So that's really like to the 1/2 power, to the 1/2 power. So it's balanced. And so we grab the coefficients. The coefficients on that, it's just going to be a 1, okay? So this entire expression here gets replaced with a 1. And then you're like, well, that's weird. Now I'm left with absolute value of x times 1. Well, that's just 1. Or I'm sorry, that's x. Right? Absolute value of x times 1 is just absolute value of x. So then you have to kind of remember what your goal is. Back up here, we said that we wanted this limit as you approached infinity to be less than 1. So we're trying to solve for the values of x that make this less than 1. Well, now you're down to just like a, 7th grade absolute value equation. To break the absolute value bars, you negate whatever this is on the other side. So you make it -1 less than x less than 1. So this is now, oops, I'm off the page a little. So this is my interval of convergence. So I can plug in values from -1 to 1, and any value that I plugged into that original thing up here would make that converge. This, by the way, is centered at 0 because if you plugged in x equals 0, it is 0. So that's centered at 0. So we knew it was going to converge at 0. And then how far did it go on either side? Just from here, you just need to make sure you're answering the correct question. The interval of convergence is -1 to 1. So they're asking here for what was the radius. Well, if you were converging from -1 to 1, right, halfway between there was 0. So that means that the radius, I'm off the page. Halfway between there was 0. So the radius goes from, 1 on either side. And that's why your radius would be 1. So when you look at the original, you basically say, what would make this whole thing 0? And if x equals 0, it's a little easier to see on hold on, let me see if there's an easier example where it's like a lot of times it'll be an expression with like an x plus 3 or something. And it's like if this in parentheses was like x minus 3, well, then if you plugged in 3, that would make it 0. So like whatever would make this 0. And that would be if x was 0, wouldn't you agree that you'd end up with 0 overall? So that's the center of this one. It ends up to be 0 for a lot of these, because when I was looking through these examples, a lot of these were centered at 0. Perhaps. I'm really mad. I thought I did number 2 right, but I can look through it later because I want to just like go through the ones that we have right. That way you kind of have an understanding. Okay, so we're gonna skip 2 and 3 because if I got like number 2 wrong, that's why I got number 3 wrong. Because they're like the same. They're related to the same thing. See, like now in number 4. So let's take a look here. Switch colors. Which way do I need to move? All right, so this is number 4, and determine the radius of convergence. So we're kind of going to do that same thing, and I like the ratio test for number 4 because I see that factorial. So again, because there was a couple that I did the root test on, but like because I see this factorial here, that was a big clue that the ratio test is like a good starting point to kind of start at. So when I did the ratio test, sorry, got stuff turned around. That means you're going to kind of do that same thing. We're taking the limit as n approaches infinity, absolute value, and then wherever you see an n, you replace it with an n plus 1. So you get x to the n plus 1 over, and then watch your parentheses here because it's n plus 1 plus 8, that whole thing factorial. And again, it's divided by the original, but that's the same thing as multiplying by the reciprocal of the original. And we want to do that because that way, you know, stuff will line up to cancel. And that's in absolute values. So there's my setup. In the numerator, right? Yeah. Perfect. And now this one might take a little bit of work. I don't know how much you did with factorials. So if you combine these, this ends up to be n plus 9 factorial. And do you know what a factorial does? Okay. Okay, so it's easier to start with the one with the bigger number. So like, what does that mean? N plus 9 factorial, what it really means is n plus 9 multiplied by n plus 8 multiplied by n plus 7, and it like keeps going until you get to a 1, okay? Not n plus 1, but like until you get to just the plain old number 1, which you wouldn't know how far to go. So we just kind of represent it like this. And if I kind of did that same thing here, this would, in the numerator, it'd be n plus 8 multiplied by n plus 7, dot, 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 times 2, you know, until you get to times 2 times 1. The goal that you're looking for is as soon, oops, my pen cap just went flying. As soon as these match, so like this was not a match with any, but as soon as you have a match, then this will take out that entire thing. So as soon as you have a match, you cancel everything to the right-hand side. So this is gone, and you're left with just the n plus 9 factorial in the denominator. So I'm going to kind of recopy this because now I've got all these things canceled. So you rewrite it as the limit as n approaches infinity. We still have the absolute value. As far as the x's go, we just had x to the first power in the numerator, so I'm just going to say x. And then this thing was all gone. In the denominator, I was left with n plus 9. Notice there's no more factorial on it because the factorial got like taken out. Okay, so I've got that in the absolute value. So we're going to kind of do the same thing as we did before. we're concerned about the limit as n approaches infinity, not x. So you take that x and you kind of treat it like a constant. You're going to pop it out front, still in its absolute value bars. So you have the absolute value of x, limit as n approaches infinity. And so you're left with 1 over n plus 9 in the absolute value bars. And then this, you're going to kind of do it the same way. It's a horizontal asymptote rule. So you're saying you're taking a limit as n approaches infinity. As this n gets really, really, really big, it's going to be 1 divided by, a billion. Or you could say the degree is larger in the denominator, and big booty bottom drops you to 0. The other way to think of it is 1 divided by a million d billion d is really tiny. So this piece goes to 0. Now, that's going to be kind of crazy because now you're left with absolute value of x times 0. Well, anything times 0, right? That's just going to be 0. So here you get 0. And you're like, well, what does that mean for like my answer? Remember our goal. We're conducting a ratio test to prove convergence. A ratio test proves convergence when you get that limit to be less than 1. So you're like, well, when will this? Like this is kind of the part you're kind of stop after you evaluate the limit and you're like, for what values of x is that less than 1? Well, does it matter what value I plug in for x? No, because you're going to multiply it by 0. So no matter what value you plug in for x right here, you're going to be 0, and 0 is less than 1. So this converges by ratio test for all x's. Almost, Amelia. Tomorrow is Amelia's birthday party. Amelia's birthday, and she's been asking me to open a present all day long. And I told her she had to wait till bath, and she normally takes her bath like at night, like later, and she like already took her bath. She's like, "Can I open my present now?" Little stinker. So, okay. So, does that part make sense? Like, no matter what you plug in for x, you're gonna multiply it by 0, so you end up with a number that you're gonna end up with 0, which is less than 1. So well, when they're asking you for the radius of convergence, remember there's those 3 options. You either converge only at the center, you converge for all real, like all values of x, or you converge for a set of them. So like, I can't imagine they'd give you one where it like didn't converge, because that would mean, like, it would mean that in this, like in the original, there was no value that you could plug in for x that would make it 0. So that would mean like there was something in the denominator, or you know what I mean? Like I mean, I worked 1 through 7, I think, and I didn't get any of that. Like for these, it should be one of those 3 options, that you converge only at the center, that you converge for all numbers. That's what we just got in the last example. And then like, this is the one that's kind of like more work, when there is a set where you need to like solve the inequality and figure out what values of x make it less than 1. Okay, so I think so yeah, since that converges for all x's, so when you look at your answer choices, that's why, your interval, and just, make sure you're answering the right question. So your interval of convergence, if you converge for all x's, it's negative infinity to infinity, but they're not asking about the interval of convergence. They're asking for the radius. Well, that means your radius is infinity, right? And I think that was the answer to the question. Oh, which then that kind of gives you part 5 then, right? It's just weird because like Like normally I solve my interval of convergence first and then go back to my radius, but this problem kind of had you, it asked you for the radius first, so that's how I do it. I don't know.
After mommy's door. Daddy, why is Ryan not opening the fridge?
Yes, because it is going to be symmetrical from the center. Like you would not have an interval, like if you were centered at like 3, you wouldn't have a radius of 7 on this side and like 1 on this side. It's going to be the same on either side. So that's a good question. And you can kind of notice that, like kind of looking at your answer choices, like for a lot of the other ones, see how like you could tell that these are centered at 0 because like, you know, that's right in between all those answer choices, and you'll see that kind of throughout the homework. Okay, so we got 3 out of 12. That's not very good. Okay, we'll just keep plugging on. Now I feel bad. Okay, so we did 4 and 5, right? Okay, so then, sorry, I have a little cough that I can't seem to shake. Man, I'm going through copy paper left and right. You have to steal some more from Oak Ridge. I know. Well, and now, do you know we're going to have a new principal next year? No, like Mr. Johnson retired. The one that was at the 9th grade, that bald-headed white man. Lavecki. Yeah, he should be okay. His son has a crush on Amelia, so I think I'll be all right. Okay, now hold on. Okay, so pull up your little module thing. And then for number 6, I hope I got this right. Oh, now I'm nervous. For number 6, I got, my answer was like -8/7 to +8/7. So I think it was choice 5. Okay, so let's go through that one. Woohoo! And then, okay, I just don't want to, like, tell me if you got to go. I don't want you to feel like, okay. So we could probably at least get through this one. Oh, and this will be a good one to go through because this is the root test. So, I don't know, because you said you didn't really go through the root test really, right? Okay. All right. So the root test worked better on this one. I had to like really think about it because I don't have to teach the root test in my class. So I was like, oh, all right. So if you're just, yeah, this is the root test. And it goes nice too with the ratio test because it's still the limit as n approaches infinity. So that part's the same. But now what we're going to do is we're going to take the nth root of it. So we're going to say the nth root, okay? And then you basically recopy that whole big thing in absolute values. So you just kind of recopy it was 7n plus 4 over 8n all raised to the n. And then that multiplied by x to the n, okay? So you've got that, and how about I give myself a right-hand absolute value bar? Okay. So what's nice about this then is that, remember just from your kind of old school stuff, if you have like the square root of 9x squared, that's equivalent to the square root of 9 times the square root of x squared. And you can kind of clean that up. So you're going to kind of apply that same idea to this. You're going to kind of break it up into 2 pieces. And by the way, for the root test, you're still trying to get the limit to be less, the limit as you approach infinity of this whole thing, less than 1 again. So that's just like ratio test, which is nice because that's one less thing to remember. So we're going to take I'm just kind of breaking this up. I'm saying that that's equivalent to taking the nth root of the 7n plus 4 over 8n raised to the n and then multiplied by the nth root of x to the n. Okay, and I'm going to kind of go off to the side again on you. So remember, like, what's nice about taking if you take the cube root of a perfect cube, right? Or if you take, let me not even do a number, it'll be easier to do it. If you take the cube root of x cubes, cube roots kill cubes, right? Just like square roots kill squares. So nth roots kill the nth power, which that's going to make this like way nicer to deal with. And again, these are absolute values, but it's not really, it's going to be a moot point in a minute here. So this nth root kind of kills that off. So I didn't evaluate the limit yet. I still have my limit as n approaches infinity. Okay, those kill each other off. So you end up with 7n plus 4 over 8n. This nth root kills that. So you end up with x. Okay, so you got something like this. And you're like, okay, well, same thing, just like when we were doing ratio tests. I'm concerned about the limit as n approaches infinity, not x. N is the thing I'm worried about. So I take this x, pop it out front in its absolute value bars, and then I'm worried about the limit as n approaches infinity of that 7n plus 4 over 8n. So now your goal is to evaluate this limit. This is balanced, right? The degree is the same in the numerator as the denominator. They're both just a plain n. So when it's balanced, you just grab the coefficients. So this whole thing is replaced with just a 7 over 8. And this absolute value of x still comes down. And then this is like, I feel like sometimes you get so tangled up in the algebra that you kind of forget what you're doing. You're conducting a root test. Your goal in this problem is to find what values of x make this converge. Well, a root test converges when this whole hot mess is less than 1. Well, to get rid of absolute value bars, we have to make it positive and negative on either side. So I'm going to say -1 less than, I'll write it as 7/8 x less than 1. And now you're solving for x. So you multiply both sides by 8, right? So multiply both sides by 8, and you get this. Divide both sides by 7, and voila. Of course, my dear. So like, how did I go from here to there? So you, like, to break the absolute value bars, like, you take whatever it is on the right-hand side and you negate it on the other side and then solve. Like, think of like just something like super easy, right? So like, if you have the absolute value of x minus 2 less than 1. Well, I agree, like, you might have done it, I wonder if this would look more familiar to you. And then you could solve this, because some teachers used to do it, oh, that's a 3, I'm an idiot. So if you plug in the number 3 here, you're gonna get 3 minus 2 is 1, right? And then 1 is, well, like less than or equal to 1, right? But if you plug in -3, or like you could plug in a 1 there, like if you plug in a -1 less than absolute value of x minus 2. Oh, get rid of these. Do that. So if you add 2 to both sides here, you're going to get 3 less than x. Oh, that doesn't add up to 3. -1 plus 2 is 1 less than 3. So now if you plug a 1 in here, 1 minus 2 is -1. -1 absolute value is 1. So it would still solve the equation. So like, to break absolute value bars, you just take whatever this is and you negate it on the other side. Oh, and then one thing, we kind of got lucky on this one. So, I didn't even notice on the answer choices, to be honest with you, dear. So, see how number 1 and number 5 are the same answer choice, but with one has a bracket and one does not? You're supposed to check your endpoints. I didn't even realize that when I was solving it. I was like, ooh, -8/7. That's what I got. That's an answer. Yay. So you have to, like, once you get to here, you have to go back and check your endpoints. Hold on. Oh, how the heck do you do that? I know that I just want to look this up real quick. No. Yeah, there is a thing where you have to check your endpoints, and now I'm nervous about it because, okay, I said you need to check your endpoint. So you have to take that endpoint and actually plug it into the original to see what it does. We kind of got lucky here because, like, when you do the ones where you solve, you should be kind of checking these endpoints way back into the original. If I plugged in -8/7 for an X value into, where's that original? Oh, I don't even know what you're looking at. Hold on. Sorry. Into that original thing was here. Like, I didn't even think to check the endpoints, but we should be. That's -8/7. I wonder if there's like a better way to do that. I can think about that, and I'll think about the endpoint question, endpoints, and I can get back to you. I'll think about it while you're at your next class or whatever, and then see if I have like a better thing. Because, like, yeah, I didn't even notice that was a concern, but I know. Oh, okay, so that'll help you. Okay, so we got that one right. And then just so you can check these other ones for 7. I got, okay, so I got like -3 to 3. So it's either going to be 2 or 6. I hope one of those is right. Let's see if I plugged in 3 into the original. It'd be 3 to the n. I don't know which one. Should we take a guess at one and see? Or do you? I can go and I could go and check the endpoints too, and then I can check. Really? Oh, dang it! See, I didn't even see that. I just got excited because I was like, woohoo, -3 to 3. Okay, so this will be a good one where, like, I'll go and, like, I'll look at the endpoints on this one, and I'll, you know what I mean? Because, like, this is a good one where, like, it's going to work for one of them and not the others. So, like, I'll make sure I go and look at number 7. Okay, so did you get credit for number 4, though? Or for number 7, or no? Yeah, like, the answer to number 7 was number 4. Okay. Okay, and then this one was that. So I'll have to go back and check. And then, did I do number 8, or was 8 the one that I got really frustrated on? Or is that where I left off? Sorry, I have a few sheets of paper around here. Number 6. Okay, it looks like I got to number 7. That's as far as I got. Really? Why do I feel like I thought I did number 8 though? Hold on. I don't see it. Okay, well, we got a few of those. I'll because you got to go in a couple minutes here anyways. So I'll take a look at like 7 and try to figure out the endpoint business. and I'll see if I can get a few more done. But like, what's your grade on that now? It's like not even a 50, is it? Oh God, that's terrible. All right, well, I'll see if I can get a few more of these done for you. That way we can at least get a couple grades in, and then you'll at least like guess on a few of them before it's due at 10 p.m. Okay. Okay, and I'll try to at least look at that number 7 and try to like work out like nice and neatly like why those intervals. I gotta think about that for a second. I haven't done that in a hot minute, Brie. Okay, I think I remember getting it. I like wrote it. I think I like jotted it down on a piece of paper, but I didn't like. I don't know if I worked it. So I'll try to look at that. So on my goals is so that it's yeah. Okay. Well, yeah. Send me that picture again, and then I'll try to work on that, and then number 7. Okay. Just to kind of give you an idea. That way, at least I'll know. I'll try to do the written one first, and then I'll look at that endpoints. That way, I can at least explain that to you for like next time or whatever. Okay. Alrighty. Bye. Love.